All right, welcome back. We are GAME3001 in the winter 2020 semester at George Brown, and it's week 6. We're talking about pathfinding again. We kind of started setting things up last week, and we're going to continue doing stuff that we did last week, this week. So let's bring up our project. Again, we're looking at our previous project folder, which was 5D. I'm just going to make a copy of it here. We're going to create 6D. And if you want to download it, you can go up to GitHub. And if you want to download it from GAME3001, the winter 2020 semester lesson 5D, this one, that's up on GitHub of George Brown College. Okay, that's where it is. And that's what we'll be doing. We'll just change this name from 5D to 6D. So this is the one we're using. And what I want to do here is just redo the Git folder so we can put up our Git repository from here. So again, I'm going to go to command line, and I'm just going to drag and drop from here. And what I want to do is git remote remove origin. And I want to say that I want a new remote, so I need to create that up here. So I'm going to get new game 3001 in the winter 2020 semester, and it's lesson 6. Grab these last 2 lines of code, copy, go back, right click, and enter. And that should put us on track in terms of our Git repository. So we're going to be watching this Git repository this week. Okay, so that's this one. So far we have 3 commits. We're going to add to those as we continue to work. All right, now that we have this, I'm going to go into the Visual Studio side. Here we are. On Visual Studio, I'm going to run it and see what we have so far. So challenge number 1 for us. Now let's discuss it and we'll just do it together, right? Thank you. It seems like every time we record in this classroom, there's always someone playing with the doors outside. All right, so if you notice here, we have our scene. If I press 1, I can go to our scene. We have our grid, but my poor ship, it's sitting outside the grid. So challenge number 1, how do I position this ship so it's on the grid? That's number 1. 2, whenever I press the M button, or maybe a button that's up here on IMGUI, I want to randomly spawn the ship in different positions. Okay? So how do I do this? What would be your approach? So I want to put it on the grid, and I want to randomly spawn my ship in different locations. What would be the first thing you would do here in this case? How would you approach this problem?
Change M ship to ship factor with 2 or 3.
Could do that. But I want to make sure that the ship is positioned properly, and I want every time I press the M key, I want to randomly generate a position on the grid that my ship's going to appear in. I want to do this again for other objects too. This is not the only object I'm going to do this for. I'm going to do it for my ship. I'm going to have a planet. I might have some actual other randomized stuff. I'm going to create a random scenario every single time I press the button. And there's going to be 3 buttons. Randomly place my ship, randomly place my planet, let's say, and maybe randomly place my obstacles, right? So I can respawn everything every single time. There might be a respawn all button, another 4th button of just everything is respawn, right? And randomly generated every single time. So how do I do this? What would be your approach? How would you start? And this is the thing where everyone struggles. How do I start? I want to randomly position my ship. Well, where am I positioning my ship? The place to start is in my solution. I would probably start somewhere in my placing, right? So here's my placing.h. Here's my placing.cpp. So my placing.h right now, I have a ship and a tile. I don't need the tile anymore. I've got a grid of tiles. right? And I build my grid. That's what I'm doing right now. Okay, I want to respawn my ship. Well, that sounds to me like I need a function. So I would build a function. I would call this m, so it would return void m underscore spawn ship. That would be the first thing I would do. So I want to build a function. And then let's just generate the implementation for that. So here it is. So how would this spawn ship work? How would this work? Well, I need to get a random number from 0 to, let's say, my grid size, -1, right? I can do random numbers if I include the util.h, my util library, because I made a util.h. And util.h has something called random range. Let me show you that. Under util.h, I have a random range method that I can call that returns, that takes two floating point numbers and returns a float. Okay? I don't have floating point numbers, but I can still use it. So again, I want to do this spawn ship. And I want to do this. I want to say that my random index, so let's use auto, random tile index, we'll say, is equal to an integer form of my randomization, util random range, between my 0 and my m underscore p grid size -1. Grid size -1. So this will generate a random number between 0 and, let's say, in our case, 299. Okay, so random position on the grid. That's what I said. Okay. This is going to return an integer, so I can change this to an int, right? And you know what? I can definitely make this a const, because I'm going to use this. I'm not going to change this in a second. Next is, okay, I got my random position. I want to get the random tile that's in that position and get my tile back. So I'm going to say that auto, actually it's really a tile pointer that I want. And the tile pointer is going to be the random tile that I select, right? Which is equal to the m underscore p grid and then random tile index. That's the random tile. Okay, so I've got access to the random tile, yay. And what I want to do is I want to set my position to whatever that random tile's position is, because each tile has two things, right? If I look at the tile, let's take a look at the tile stuff. Go to definition for the tile. When I define my tile, I have world position and grid position. So world position is being recorded as well as grid position. So I want to go to the world position. And I can do that by get position, right? Because the tile is a display object, and all display objects record a position. Okay? So let's go back to that. So I'm going to say that let's set my position of my ship. So m underscore p ship set position to the position of my tile, random tile, right? Get position. So that would randomly spawn my ship exactly on the tile in a random spot every time. Okay, cool. So this is good, but I need to call this function now, and I set up my ship in the start function. So if I go to the start function, I instantiate my ship here. First I build my grid, then I instantiate my ship, and then I set this position. But instead of setting the position here, I'll just do it underneath. I'll just call m underscore spawn ship. So this is where it's first spawned. It just generates a random position. If I run this now, first, if I run this, it's going to pick a random spot every time I go to the play scene, right? And let's see how this works. cool. Press 1, and then, hey, there it is. And if I press it again and go back, somewhere else. And then press it again and go back, right? Here it is again. And I want to be able to do this without going back and forth from my scenes. I want to be able to do that, right? So I want to press a button, M or this button up here, to move it around without moving from my scene. So that's the next part. So I know when I want to press the button, it's inside the input manager, which is down in here. And notice I can inspect it way out here. So there's my M. And I want to call that too, M underscore spawn ship, right? That calls it whenever I press the M button. And if I want to do it on the IMGUI side, then I just got to search for the IMGUI stuff, which is up here. Here's my button. And I do the same thing. M underscore spawn ship. But I want to rename this from button to maybe something like respawn ship. So it's useful for me. And let's see if this works now. So again, 2 places I put it. One in the input handler, which is down here. Right? Here. Respawn ship. And then one with the here inside the IMGUI function, right? If I run this thing now, and if I go to my scene, and if I press M, then I should be able to move randomly in different places. Good? Random positions. All right, I want to do the same thing with my planet. Okay, so I don't have a planet yet, but I want to instantiate a planet, and then I want to spawn the planet in different positions. Okay, so how do I do that? Well, I have a solution, my solution explorer. In my game objects, here's my game objects, I have a planet object, right? So in my placing.h, I can include that. So ship tile, and we'll also include planet. Here's my planet.h. And now that I've included that, I can make one planet pointer. Sure. Okay, it's my planet pointer. And then I can go to the start function, so go to definition. Here's my start, and just like I did with my ship, I can make my planet. And now, things, do you want your planet to be underneath your ship or above your ship? That's the draw function, but I probably draw my planet first. So I'll say that I want to instantiate planet. And add it to the display list. So the way I do that is M underscore P planet is equal to a new planet. I'm allocating memory. I'm adding to the display list, which is M underscore P planet. And eventually we're going to update everything display list order. For now, no. And in my draw function, I draw my planet first. Well, first I draw my tiles. Then I draw my planet. Then I draw my ship. We're using the correct layer order. Cool. But I want to make another function called spawn planet, right? So in my placing.h, I'm going to go to this underneath my spawn ship and make a new M underscore spawn planet function where I'm going to implement it. There it is. And you know what? I can probably copy all this right now and put it in here. Uh-oh, I should copy. That's a bad word, right? Copy means there might be another way of doing this with only one function, not two. Okay, some random tile, sorry, that's planet. Okay, so that's this, cool. And what I want to do is, just like I did before, go down into this area here, and under where it says P, let's call that function. There it is. Oh, how about the spawn planet? That'd be good. Spawn planet. There we go. And I also want to do it inside the buttons. So I have a respawn ship, and I'll just do a respawn planet button. Respawn planet. I'll just change the names of the buttons this way. And m_spawn planet. Cool. That's good. Let's see if it works. So I run it. But I have a problem. I want to see if you guys can tell me what the problem is going to be. It's subtle, but I mean, not subtle. It's there in your face, but you know, you may not understand it until you see it. Let's see. I have a couple problems, but this is one of them. Okay, so here's my ship, and my planet's like way out here. What happened? How come my planet like populated way out there? What? Well, no. If I press planet again, I populated in here, but I don't know what happened. Well, because I never did anything. That's inside the start function. I never told it at start to spawn the planet, so it didn't. So I'll do it here. m_spawn planet. So that's why it went to the corner by default. Let's try it again. Right, so I got my ship and my planet, and if I press P again, it can go in different places. But what's the danger here? What's the problem? What can happen? Yeah, I can have the planet and the ship be on top of each other, and I don't want that for pathfinding. So how do I check to see if the planet's already there or the ship is already there in the same grid location? I could check, yeah, I can make a function. But remember that I also have other structures that I could use. One thing to note is, and there's different approaches here, but I know I have this. I have a grid. My grid has tiles. My tiles know position, and they also know grid position, right? They don't know about anything that's on the tiles right now. All they know is, here's my grid position, okay? That's what they know. But they also can know the tile state. Right now, these little dashes mean undefined. That's what those little dashes mean. And I want to set the tile state when I move my ship so that it's the start state. My ship is where we start. I want to move my grid, my planet. Whenever my planet goes somewhere, it's the goal state. That is where my goal is going to be, right? So I can check to see if, when I randomly spawn, if the actual place I'm going is not an undefined, then don't go there. Keep looping until you find a spot where it's undefined. That's another way of doing it, okay? So in my spawn functions, let's go to that spawn function. So spawn ship, here it is. I want to check to see if it's undefined, right? But I have to set it as undefined first, which means that's a tile thing. So in my tiles, tile.h, let's bring that up. We'll also bring out tile.cpp. My tile.h, I do the following. These are the different states: open, close, start, goal, and undefined so far. Okay? And when I go to my tile constructor here, go to definition, I set it to open, and that was kind of what I did last time. I'm going to change that this time, so let's get rid of this. And this is in my tile. Let's move this away from my tile. Okay? And what I want to do is when I instantiate each tile in my grid, which is in my placeScene.cpp, in my build grid, this thing, I want to set my tile to undefined. However, I want to show that somehow. And in my tile.h, I have a set tile state, and I also have set tile state label. All right? Let's go to set tile state for a second. Go to definition. This is in my tile.h and my tile.cpp. Sure, I get the state and I set the current state of the tile, the member variable to state. I also check to see if it's the goal. I don't need this part. I can see if it's the goal, and if it's the goal, set my tile value to 0. That's okay. That's okay. But what about my tile state label. When I get a new state, I want to set my tile state label here as well. So I want to call that set tile state label to something, some kind of string. But it really depends on what the state is. If it's open, it should be an O. If it's closed, it should be a C. If it's start, it should be an S. And if it's goal, it should be a G. And if it's undefined, it should be a dash. I want to be able to set that up. So we'll do a switch case in here. Switch case on the state. Case, if it is open, then if it is closed, then do something. If it is start, do something. Case, if it is goal, do something else. And finally, if it is undefined, well, then do something else. So this is a little switch case that basically determines what my set tile state label is going to be. So I take this, cut it, go into my open, and then set my tile state label to O. When it's open, my tile state label is going to be O when I set my tile state. And let's do that for closed, for start, for goal, and for undefined, and just switch the symbols. So closed, start, goal, and undefined. Okay? Again, I'm just using a switch case for this. And so what this will allow me to do is when I set the label, I can, not just the values being set, but also visually I can see that it's open or closed or undefined. And this is going to help us next week when we actually do the first pathfinding stuff. We're going to do a first heuristic where I use Dijkstra's algorithm to find all the paths, right? Or something else. Maybe we'll use A star. I don't know, right? And I'll find all the paths. Okay, so now that I have this structure, then inside my placeScene.cpp, inside where I define my tile, I add the tile to the grid, and then when I do that, I want to set the tile. So I want to set the tile state to a new state, which is going to be undefined. So by default, all the tiles are undefined. By default. Every tile that I add to the grid. Okay? Next, once I've done this, then when I spawn my ship or my planet, I want them to change the tile state, whatever that is, to the start or a goal. Now there's duplication again, but whatever. We can say that our random tile set tile state to start for the ship, right? And the same thing goes for this random tile, whatever that random tile is. For this, you can see I'm copying, right? And this will be goal. But this is going to cause a problem, right? Still, even if I was to do this, and if I say that, well, I'm looping, again, you can see I have two functions the exact same. This bothers me already, right? And what I want to say is, while my random tile is not equal to undefined, so let's say, for example, I'm trying to spawn in a place that doesn't have undefined, it's something else, right? Then keep doing it. Keep finding a new location and point to another tile. So it looks like this. Do while my random tile, I'm going to put this inside here, my random tile, while my random tile, right? And I want to get tile state. It's not giving me code editing because I don't have it yet. Is not equal to undefined. Then keep looping. Keep looping until I find a state that is undefined. So I want to. I'm looking here. Search for undefined tile. or empty tile, empty tile. That's what I want. I want undefined means empty. I want to find an empty space. Okay? However, we have a problem. We don't know anything about random tile, and what I can do is I can do something like this, where I set up my random tile up here, and I set it to null pointer. So now we know what random tile is up here. Now look, I can do that down here and spawn planet, but let's hold off for a second, because it's going to be the exact same. We need to find another function to fix this. So first, let's make it work with the ship, and then after we make it work with the ship, we'll make another function or a template, and this way I can only do it once. All right, so first we check. We say, okay, my random tile is a null pointer. Cool. While my random tile is undefined, search for an empty tile. That's what this does. Search for an empty tile. Once I have my empty tile, I know this is random and empty, then set the tile state to start, and then set the position to what it is. So this is good. But this also presents an issue. This presents an issue. Because right now, if I run it, it causes, I solved one problem, but I'm causing another problem now. That's what happens when we code, right? Okay, so here's my ship, and if I press move, oh man, it left an S behind. And another one, and another one, and another one. And if I keep spawning enough times, well, it's going to come to the point where there's no place to go. Right? Because they're all taken by S's. Starts. And this is no good. Right? So we got to figure out a way, not when we leave one tile, we got to mark it as undefined again, and then go into the next tile. So we know I did this so we can see that indeed S is working. We are getting a random tile position. Okay? But now I need to know about what tile I was in, and whatever tile I was in before, I want to mark that as undefined before I move. Before I do this, random tile, whatever, before I get my new random tile, right? So it's like I want to say that search for the position that I'm at right now, before I set position, search for the tile that I'm at, set the tile somehow. Well, luckily the ship itself, here's my ship. If I go to my ship, ship has a get tile and set tile, right? Well, this is cool. I can get tile and set tile. So I can set a tile initially to something. And then when I go back and do it again, I can reset the tile to something else. I can make a pointer to the tile that I'm actually on, right? That's what this is allowing me to do. I can get my current tile, whatever that is. And it's important because then I can read the current, where my current spot is every single time. Wherever my ship is, I know what tile it is, and I can get the value from that tile. I can read the tile value in front of me, right, kind of thing. Okay, that's what this allows me to do. Okay, cool. So let's go back to my placing.cpp. So, okay, yeah, I do this, and then, well, down here, I'm doing that, and then I set the tile, right? So I'm going to say that m_p ship, right? I want to set tile. My tile is going to be set to the new random tile. That's where I was, and now, well, when I leave, I want to, if my random tile is not equal to null pointer, so I'm not doing this for the first time, because the first time I would cause a problem if I was trying to undefine it, right? But if it's not undefined, if my ship itself, I can go down here, right? And again, I'm just doing this in whatever order, arbitrary order. We're going to fix up the order in a second. I can say that if m_p ship get tile is not equal to null pointer, so I'm actually pointing at something, then I want to do this, set tile state, whatever my tile is, so m_p ship get tile, and then I want to set tile state to undefined. So I won't leave a mark this way, but only if it's not null pointer. If it was null pointer, that means I never did this once, right? And so if I try to set something to undefined that doesn't exist, it's going to give me an error. So I'm preventing this error by checking to see that it's not null pointer first. But hey, let's make sure that get tile or the tile itself is never null pointer. So that's in my ship.h. You can see that I have this current tile member variable, and maybe somewhere in the constructor function in ship, maybe, I'm hoping, that I set it to null pointer. Well, actually set to null. Let's change this to null pointer. There's null pointer. Okay, so now I've set it to null pointer for the first time. So when my ship is created, it is null pointer. So this should work, right? And if I run this thing, then we're good to go, right? So what I mean is, if I press play and if I press my M for ship, now wherever I go, I reset it back to undefined, right? A bunch of times, right? And it's no problem. I can keep setting it back to undefined, 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 undefined. I want to do the same thing for my planet. And right now, the way I've set things up, it's bad, guys. It's really bad, right? I mean, I can duplicate everything I have here again inside this function. That's pretty much brute force if I wanted to do it that way. And I don't recommend. I think that's a negative, right? So I would like a function, whether it's a template function or another receiving function, to somehow do all the work for me, no matter what object I pass into it. No matter what the object is, I want it to do all my cleaning. I want to set the old one to undefined. I want to set the new one to whatever it's going to be. The only specific thing that I can't do in my function is do this random tile thing to goal. I can't, because that's where the planet and the ship will be different. The planet will be start and my my planet will be goal and my ship will be start, right? That's the difference. The rest will be exactly the same. So let's make a new function, and we're going to have problems. But let's make a new function called spawn m underscore spawn object. Spawn object is going to spawn any object. It's going to take a type of display object, pointer. We're going to call this object for now. So I'm going to pass in the object that I want to spawn, whatever that object is, right? And whatever it is, I'm going to move it in a random space, clean up where it was before, and set the proper the state to the proper amount, the proper thing, whatever it is. Okay? I could pass in, if you really want me to, this is another optimization, so I don't have to even return anything. I could pass in, then I don't need these spawn ship and spawn planet things if I don't want to. The type, I could. And then the spawn planet and spawn ship would just be like a one-liner, right? I could do that. But let's just keep it like this for now. Also, what I want to do is I want to return the position. I want to return the position in the grid of the where I spawn it. Wherever the grid is, I want to spawn it, so it must be an int. Let us generate my implementation. Here it is. All right, so what does this look like? Well, for now, let's just copy everything that we had from the planet, or the spawn ship, all this stuff. And now, my friends, we come into our problem. What I want to do is I want to exchange ship for this object, any object. But what is the problem with that? If I did this, I go here as an example, and I press Control F. I'm searching for ship, and I'm going to change it with object and click, replace all in this selection. So I did that. Yay! I'm pretty happy about that, but I'm not, because I got this problem. Why do I have this problem? By the way, also, I need to return something. I need to return the grid position, which is my new random tile index, right? And I can't do that because it's in the do while, so I got to put it out here. So I got to say that int random tile index is up here. We'll set that to 0. And then we'll return random tile index down here. So why am I doing this? So I can keep track of the grid position. Guess what this does? But I got this set tile and get tile. Why are we getting these errors? I mean, ship had it. So why does object, which is also a display object, not have it? Well, because, my friends, ship and planet, they're the only ones that have those functions. But display object, not every display object needs like tiles, right? For example, my tile is a display object. How the heck am I going to put that on the display object? That doesn't make any sense. So what I could do is use a template function here, or I could make a separate class called Pathfinding display object, a specialized class. And this is my approach for today, okay? Because you guys are just kind of learning templates, right? So I don't want to use templates because templates can be confusing for new people. Hell, they can be confusing for me sometimes, right? When you put things together. All right, so this is good. So let's make a new class, solution. And we're going to make some changes. So this is where the changes come in. In my header file, I want to make a new class, add new item inside the source folder. Here it is, source folder. I want to make a new header file called Pathfinding display object. It's pretty long. Pathfinding display object, there it is. Right, I want this. .h. Okay, we'll come back to this in a second. And then in the source files, I want to add a new item, the CPP side, Pathfind display object to CPP, add that into, and then include automatically a reference to Pathfind display object.h. I know I want to make a class. I'm going to go fix the pragma in a second. I'm going to make a class called Pathfinding display object, which is going to inherit from a public display object. That's what I want. And you can see that in here, I want to use display object.h. Same thing as we normally do, except that I want to make my guards. My guard function has got to be my if not defined pathfinding, or we'll say path finding display object, right? Then I'll define that. And we'll use the end if. Okay, so that's my guard. I want to make this an abstract class again, just like the display object class, because you can't instantiate an object of type Pathfinder display object. You're going to have ship, you're going to have planet, maybe we'll have mine in the future, other things. So here I want to just make this virtual. So first in the public area, I want to have my virtual destructor. So first I'll make my constructor, and then I'll make my virtual destructor. Okay, I need those two. And I also need to include other members that I didn't include. So, sorry, not that one. This one. And I want to make this equal to 0 because they're also going to be virtual here. Now, we're going to make sure we take this away later. For now, I'm just making it so it's its own thing. Okay? And I know I need the other functions from the ship. The ship has two functions, get tile and set tile, which I only want my pathfinding display object to have, not my ship. So I'm going to just copy this and put it in my .h. Okay. Notice I need a reference to tile. Tile is a display object, but a specialized one. Now if I include tile in here, because tile is the display object and this is a display object, I will have potentially a cyclic reference. So instead of that, I will make it friend. Okay. So my tile is a friend class of this thing. I'm actually forward declaring. That's what this is. And I also want a private area where I define the member variable that I need. So in my ship.h, if you scroll down, I have this current tile. And I'm just going to put it inside of my private area. Are you with me? I'm just defining my new display object, pathfinding display object. That's what I'm making, right? And my pathfinding display object is going to be a specialized version of display object that has two little functions, get tile and set tile, and one little member variable that's different, m_current tile. Again, is this the only way to do it? No, there are other ways to do it. This is the way I'm thinking about doing it, right? Later on, we may loop back and refactor this thing and do it a different way. Okay, so now that I've got this, I'm going to go to here and use ReSharper C++ to generate definitions by declarations. I don't need the draw, update, and clean. I don't need to draw those ones because those are going to be just zeros. But I do need get tile, set tile, and these ones. So let's just press finish. So I only need this. In my get tile, I'm going to return m_current tile. And in my set tile, I'm going to say that m_current tile is equal to new tile. So that's the only thing I need to put in here, just like normal. My destructor can be defaulted. My default constructor, my destructor. And my constructor is going to set up my current tile as 0. So I can say that current tile is null pointer. Okay? Make sense? Again, I've just made a new specialized class, right, that allows me to inherit from it, and I'm going to set my ship and my planet as pathfinding display objects. That means that they're going to both have a get tile and set tile function, right? And any other pathfinding display objects I create will also have that capability. Okay? Cool. We don't need these anymore. Let's go back to my ship now. So my ship, instead of it being a display object, let's make it into a pathfinding display object, which means I got to change this to pathfinding display object. Okay. And if it's a pathfinding display object, then I don't need these because they already exist in pathfinding display object. I can get rid of this, and I can get rid of the tile. And since I got rid of the tile and that, then what I can also do is in my ship.cpp, I'm going to have some errors now. For example, I've tried to initialize something that's already been initialized. I don't need that anymore. I'm just going to follow the errors and get rid of them. I don't need to clean those because this should be cleaned actually in my pathfinding display object. Let me just go do that now. So in my clean function of my pathfinding display object, I need to do this, right? But for now, let's just get rid of it. And these can all be gone. These ones here, I don't need these get tiles and set tiles. Hey, I did this for the ship, right? I need to do this for the planet as well. So let's just get rid of the ship now. I don't need that anymore. Let's pull up the planet. So I'm still not clear here. Let's put the planet up. So under game objects, planet.h and planet.cpp, right? In my planet.h, I don't need this stuff because I don't need that. That's part of my pathfinding display object, which is what this is going to be in a second, right? Pathfinding. Okay? And again, in my planet CPP, I can not initialize this. It's already been initialized. And I don't need to clean this because it's going to be cleaned somewhere else. Not yet, no. And I don't need these functions. So literally, my planet's going to be very small. Like it's not going to include a lot of stuff. Cool. So my planet and my ship now are pathfinding display objects. Let's get rid of that. And now back to placing. Well, the reason why this is not working is because I'm listening for a display object, and it should be a pathfinding display object up here. So in my placing.h, I want this to be a pathfinding display object, right? Which means this should be also a pathfinding display object. And now when I did this, we're clear. Because ships and planets have getTile and setTile, right? Before those two functions were not part of my display object, and that's why I was getting an error, because this didn't exist. It only existed for the ship instance and for my planet instance, but not for this. Okay, not for any object. But now any pathfinding display object, all of them have getTile and setTile. All right, so we've done the generic function, kind of, a very basic one. But however, I want to use it down in my spawn ship. Let's fix spawn ship. We don't need any of this stuff anymore, for the most part. All I want to do is this part. I want to say my random tile, set tile state to this. Random tile is something I want to have access to. And in order for me to have access to this, I need access to the tile index. So I want to say something like auto random tile index is equal to m underscore, here we go, spawn object. I'm going to pass in m underscore p ship, which is the thing I need, and it's going to give me a random tile index. Well, if I know what the random tile index, then I can change this part. I can cut out, and I can go down here. I don't have a random tile, but I do know that m underscore p grid random tile index set tile state to start. So that's what I can do. And I can make this a const. So that would totally work. So now I don't do it here. Here I only do all those things. I set the position, I get a random tile, I return the tile index, and then what I'm doing is just do this. I could, if I didn't want to do this line, I could just return the tile itself out of here, whatever the tile that I randomly went to, but the tile index is safer in some ways. Okay, cool. So now that I did this for the ship, right, I can do the same thing for the planet. So I'm going to copy this. And we're copy pasting, which is bad, but that's okay. Cool. And this doesn't have to be the ship. This is going to be the planet. That's it. So now the ship and the planet are going to get random positions, and they're going to be both marked as start or goal depending on where they go. Are you with me? So I've solved the problem. I don't have to make it still. This can still be optimized, right? Maybe, like I said, instead of doing these functions at all, I can just, literally just pass in not just my ship into my spawn object, but also what it should be, goal, state. And then it can be done all in one place, and I don't have to do anything. then these two functions, all they do is call one line. So that's further optimization if I want. Okay. Let's leave it like this for now. Why is my P planet like this? 2 P's. Let's rename that. That's a mistake. We need to fix that. That must be bugging you to watch it. It bugs me just to see it now. So I'm just going to get 1 P. All right. All right, so now that we've done this, we've done random ships, let's test it. So now we should be able to randomly position our ships and our planet, and there should be no intersect. I won't spawn them on top of each other. That's number 1 on my grid. And then the other thing is it won't leave a trail. When I leave from one place and go somewhere else, it'll clean up where I was before and leave it as undefined. But at the same time tracking where I am currently. So again, if I press like P for planet, I can move my planet around random places. I can do the same thing with my ship by just randomly positioning it wherever I want. And they'll never cross over each other. That's the idea behind them. Okay, random places. Okay, cool. That's part 1. Part 2, I want to get values for all my tiles based on the planet position. So wherever my planet is, each tile should have a value based on the distance between its current position and the planet's position. Okay? Well, I've built in some stuff for you. In the tile.h, I have several functions. One of them is set target distance. I want to fix this up. And we can get rid of some of this other stuff. I got like Manhattan factor, and I did this other thing last year. Let's get rid of this stuff. I'm just going to clean up my tile a little bit. I also don't care about these Manhattan factors and Euclidean factors. Let's get rid of that too. I'm just cleaning up. Okay? And let's clean up my CPP while we're at it, because I just made a bunch of mistakes, a bunch of errors. So I don't need any of this. And we'll get rid of all this. So everything inside this set target distance we'll get rid of except for the first line, which is M goal location. So we'll get rid of all this. Okay? And all this stuff at the bottom, which is just a bunch of getters and setters that I don't want right now. There we go. Okay, cool. So I want to set the target. That's what I want to do, like it says. I want to set the target, and if I go there, so set target distance. Target distance is going to be based on a vec2, the goal location. I know that I can use util. Util library has a distance function that gives me the distance between 2 vectors. So I'm going to use that. So I'm going to say that my current value, which is the distance, m underscore tile value, is going to be the distance between those 2 vectors. So util distance between my current position for the tile, this is for each tile, guys, and my goal location, which is the planet. So wherever I am and to the planet, what's my distance? That's going to be the tile value. It's going to be pretty big, because if I'm like 600 pixels away, I'll be like 600. So for now, that's not really what we want to use. Next week, what we're going to do is we're going to change this to f, the value, is equal to, g plus h, where g is the distance and h is the estimated distance. We'll get a value for that, right? G plus h. And that'll be the value for my tile. For this week, I'm just going to take my actual Euclidean distance, my Pythagorean distance, that's what this is, and I'm going to multiply it by like 0.1. So I'm going to divide it by 10. That's all I'm doing. This is a quick fix, just so I have some values. These values are incorrect right now. Okay, cool, but that's just the tile value. I want my label to be set, and we can get information about this because I've already done this label setting stuff up in the constructor. Here's my label, right? And I start off by creating a stream in order for me to take the tile value and put it inside the label. So let's do this stuff. And again, I'm copy pasting, which means, hey, we can optimize this somehow. So again, I want to go back to that. I want to get back to the set target distance function. And I want to use this. So I'm using the output stream. I'm calling it temp label. I'm passing in a fixed precision of 1. So I'm chopping off all the precision that I'm going to get from this. All I want is like 1, kind of point of precision. And then I have a label string. And the label string is the thing that I want to pass into my m_value label set text label string. And this is going to set the label to whatever the new value is. The value, this is the label of my tile. My tile has 2 labels, my state and my value. My state is like a dash, a C, an O, like we showed you earlier. And my value is that number that appears underneath the tile. My numbers aren't going to be zeros anymore. My numbers are going to actually have values now, okay? So that's what this set target distance does. Okay, but we never called set target distance. Let's call it on every time we reset the ship. I want to compute the tile values, right? Actually, every time I reset the planet, I want to do that. All right, cool. So let's go back to my playscene.h. I respawn the ship, I respawn the planet, and then I want to compute my tile values. So I'm going to make a new void m_compute tile values. That's what I want to do. And this compute tile values is a new function. I'm going to call it every time I respawn the planet. I'm going to call that function m_compute tile values. Why? I compute it, and once I've computed the tile values, I'm going to print them out. So I'm going to say that I need to do a for in for m_p grid for every tile, for every tile in the grid. That's what this for loop is. For every tile in the grid, I want to tile set target distance to this new location, which is going to be m_p planet get position. So what I'm saying is, hey, I just respawned the planet. Compute the new tile values. Because every time I respawn the planet, the distance from each tile to that planet, I want to calculate it. I want to set the value of each of the tiles to some value and display that value on every tile. That's what I want to do. So every time I move my planet, I want to have this recalculation happen. I want to compute. And I'm doing it for each tile in the grid. The grid is what's holding all my tiles. My tiles have values right now, and they know the distance between themselves and the goal location, which I'm giving it, feeding them the goal location right now. Again, little chunks of information. And if I run it now, you should see that I'm going to get my tiles that look like they're going to have everything we need inside of them. All right, so I'm going to press 1. And now we have values. So here's the planet, and let's just respawn the planet one more time. If I respawn the planet by pressing P, you can see that the values will change, and change, and change, and change. We have a bit of a memory leak, which we're going to fix in a bit. A big memory leak, but we'll fix it. All right, so let's suppose this is the value of my ship. Let's march along to these values for now. Again, these are just distance values for now. So here's my ship. Where would I go? If I was going to go to use a greedy algorithm like Dijkstra's algorithm or A-star, what is the next tile I should move to? Well, let's take a look. I can't go. Let's assume we can't go diagonal, okay? Because this is kind of what I've asked you to do in your assignment, right? Oh, I can go here, 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 or here. Those four positions, right? Well, 52.6. Let's start with that. That doesn't make any sense. 48.2 is lower than 52.6, so I could probably go there. 49.5 is lower than 52.6, but greater than 48.2, so it's either there or there, which is 44.7. So 44.7 seems to be the next spot. So I march there. Okay, now from here, what's my lowest value? 44.2 or 40.8? 40.8. We march to this point. Okay, now what's my lowest value? 36.9. Now what's my lowest value? Right? From here. 36.2 or 33? 33 is my lowest value. Okay, now we're at my lowest value. 29, 25.3, 21.5, 17.9, 14.4, 11.3. Uh-oh, wait. Now I'm in trouble. Because I got two values that are exact same. 8.9 or 8.9. Now we branch. Which way do I go? Do I go toward the right? And what is the right? Or do I go to the left? Which way do I take? Right? And you need to establish you can make it random if you want, but you need to choose one side or the other. Am I going to go towards the right of my facing, or am I going to go towards the left? Let's make it so that we always go right. So because these values are the exact same, 8.9 and 8.9, I will go to the right. So this is my first branch. Let's mark 11.3 as someplace I need to return to. All right, so 8.9. Okay, where do I go now? 5.7, because that's lower. Where do I go now? Uh-oh. 4.0 and 4.0 is the exact same. Well, I'm going to go to the right because that's what we're doing. So I'm going to go to the right, 4.0, and then down in here. Okay, now I back up. That's one path. I can also go this way. It's the same. Back up. Okay, cool. I back up to this path. I went this way that last time. Let's go this way. Let's see if it's shorter. No, it's the exact same. Okay, same length. So I'm here now. So either whether I go this way or this way, it's the same length. Choose one, whether it's right-hand rule or left-hand rule. Choose one way and pick that path. That is the default path. And that's how I would travel to this thing. Okay? Does that make sense? Now, these values are wrong, but the idea behind them is correct. Okay. Let's put together something else. What if, in front of this thing here, I had a wall that started off at 22.6, this area, this tile right here, and spanned all the way up to 25.6. So from 22.6 to 25.6 is a wall. Now what do I do? Okay, well, let's go back to this again. So 44.7, right? I would go to 40.8, 36.9, 33.0, 29.1, right? 25.3, 21.5, and then, my friends, we would get to a wall. And this, let's say this wall here would be like, positive infinity. It's like really, really high. It's impassable or whatever. You couldn't check here, right? Okay, so the wall goes up to 22.6, we said, right? Or something like that, or 25.6. But there's a wall all the way down, right? All the way to 22.6. So I'm here. Okay, well, what's lower, 23.3 or 20.4? Well, 20.4 is lower. Uh-oh, now I'm in trouble. Look, I go down, I go down, I go down. Uh-oh, wait, now they're the same. They're the same, right? I went down here, and I can choose this way or this way. Well, they're the same distance, and I should try and go this way. I can't go here, and I've already gone there, so I'm going to keep going down. Okay, and now it's climbing. Look, it's going further and further away. And I come to this point, and I've closed all these ones off, right? And I can't go here because this is positive infinity, so I'm at the end. So what do? I march back up. 1, 2, 3, 4, 5. Until I get to a place where I was here before. That's my last place. I never traveled up here. Let's go up. I go up here, right? I go up here. I go up here. These are the same, right? I mark this one closed, right? Because I'm going to go, actually, I remember my rule is to go to the right. So instead of going this way, I go this way. So I go here. What's cheaper? Well, that is. Okay, I go here. What's cheaper? Right? I can't go here, and I can't go here because those are marked. I can go here or here. I go here. So I kind of did a bit of a loop there to do that because that's my heuristic, right? And I'm way up here now. And now I'm going to go here as an example. Then from here I can go here and then follow my way around the wall, which is to go down this way until I come to a point where there's matching, like right here. See, and where it happens, right? Why it's here? Because 14.4 and 14.4 are the same, and because we have this diagonal. On the diagonal, we're always going to get these branches. So in your assignment 2, the constraint that I gave you is you cannot move diagonally. You cannot move diagonally. Okay? Yeah.
So when you want to into a tile and close it, so how do you know which path to take to get back up and around? Like, when you
So I wouldn't mark where I'm coming from as closed. I'm going to mark only what is in front of me as closed. Oh, sorry, to the sides, the ones that are higher values, right? So if I'm going from a tile that is open, I'm just going to move towards the tile. I'm not counting my own tile. I'm moving towards the tiles that are open. Now this is where we came into a problem here. If we follow the logic, and again, I'm going back to this point right here. So I went to here. This is the line. Let's say we're making a line right here, right? Come here. I'm going to start going down, but then we come to this point. This point here, where it's next to this, but there's a block over here. Some kind of way. It's impassable. Okay, I'm leaving this tile open, and I'm going here, and I'm checking the tiles around it. So I check this one and this one. This one is higher, so I mark this as closed. This one is lower, but this one is equal to this one. So either I go up or I go down. Well, I've already been here. That's where I just came from. That's the previous tile, right? So there's got to be a way for me to know where I'm coming from, right? I don't want to go back here. So I want to go down there. But now when I come down here, you can see that, well, this is open, right? I came from here. I'm not going to go back that way. I can go here or here. I close this one and I go down this way. Okay, I can go, this one's lower, but I'm not going to go back. I can only go forward. I can go here or here. I choose to go here. I can go here or here, and I choose to go here. And when I come down here, this is closed. This is closed, and the only choice I have is to go back. I start marching back. So then I start marching back until I get to here. Then I realize that I can only go back. And now I come to the point where I was before. This is my starting point, right? And then I come back up here. And then I go here. And then I go here. And I come to the point where both of those are the same, and I just chose to go this way. Now, if I used the left-hand rule, I would have found a better path. I could have gone up. But instead, I went this way, right? So the first time I tried it, I went this way, around, right, back over here, and then down. Then I'm going to go back around again after I calculate the first path, come back to this point here, right, march back, come here, go back up this way. So is this farther? Yeah, it's farther by one tile. So my new path is going to be this way. And then when I find my path, I'm going to close this one off. I'm going to mark all these ones as closed. And that'll be my new path. And when I press the button to move, it's going to move there.
So you're basically searching for undefined. If there's no undefined, you search for open.
And the problem with that is, if I search for open and I go back up, right? The one behind me, I got to make sure that, because that is now open, right? If I have two that are open, I'm going to go to the least cost one. Okay? So my problem is going to be when I come to this point. If I was in this example, because I come here and I'm going to come to this point, right? So I come here and I go, okay, I'm back up to this point now. Well, this point is open, and so is this. This one's closed. So which way do I go? Do I go back up to here and down to here? Am I going to keep bouncing around back here? What am I going to do? Right? That's going to be our problem. How do I resolve that? Right? Because they're both open. And the thing to note is, if I've been here before, if I've marched here before, right, as an example, I'm coming back up, I should close it off, right? That shouldn't be a possibility anymore. I've explored it, but that's not a path that makes any sense. I need to go back to the previous path. And the way to do that is, when I come to a decision point, so again, when I come to this point where it's the same, I have a branch. I mark this point as the point I need to come back to. So instead of me marching all the way back, I just jump there. I'm here, right? And now from here, these ones are all closed. I close all this. This is not a viable path. I close these off. I'm here now. Okay, cool. Now where do I go? Well, I'm only going to go up from here, right? I'm going to go up until I find another branch, which is going to happen, somewhere up here, right? Right next to my wall. Here. Now we have a branch. Mark it. Cool. Try one branch. Okay, cool. Now come back. Right? Try another branch. Whatever it's going to be. Okay, cool. Which one's the shorter one? This one. Mark the other one as closed. But I need to hold those two lists somewhere, right? So that's going to be the challenge. How do I do that? And because of my constraints, because I put in a constraint that you cannot go diagonally, you can only move right, left, and straight. If I move diagonally, I wouldn't have this problem. If I move back diagonally, then I come to this point here as an example, and then I come to this. Here I might have the problem. I could resolve this issue. I'm going to keep going straight because I'm going to prefer undefined. I come to here, and then I'm going to move back because now I have the only place I can go back up is open. So I mark this as, I don't even mark this, I leave it as open and I come back up. And when I come to this point right here where I make a decision, right? 28.3 and 31.2, this is cheaper. So I go to 28.8, I just cut across this way. Right? I wouldn't even go to these. These would be ignored. I cut across to 28.8. And then from here, once I make 28.8 is cheaper, right? Because this is not even a thing. I can't even go that way, right? Because I've closed all those off. Like, the way it would work is I close it off, this one's closed. And then I go here, and this one's already closed, because this doesn't make any sense. I can go here, 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 or here, if I was going to go diagonally. Well, you know what? That's better. So I close all these off, and then I go this way. So I hop this way. So it saves me a step, right? If I can go diagonally. But in order for me to go diagonally, I got to keep track of the objects in front of me, the objects behind me, the objects to the right, the objects to the left, the objects to the top right, top left, bottom right, bottom left. I got to keep track of all those different tiles every single time. I need to know what my tiles are in all those directions. And that, my friends, is going to be the subject of next week. For example, what about when I start mapping tiles and I start up at the top, in the top left corner, right? Is there a tile up? No, it's nothing. Is there a tile left? No, it's null pointer. There's null pointer here, null pointer here. I only have a tile here and here. So I set those things up and left as null pointer. If it's null pointer up and left, that's not even an option. Check to see if it's null pointer is going to be a thing I'm going to ask. Is it null pointer? If it's null pointer, then, well, we don't go there. If it's not, leave it as is. Right? Go to the next one. So, example here, I would build up my neighbor tiles. I have this neighbor tile and this neighbor tile. This one doesn't exist. This would be the bottom left. And if I was checking all the way around, then I would check top left, top right, bottom right. Right? So all these ones. Okay? And all of these ones would be null pointer. So the only ones I would care about is these ones. Okay? So sure enough, we're going to get some funky movement. Okay, now how about this? One more situation before I let you guys go. What about my ship is completely surrounded So I have a situation where it goes like this. So around 11.3, it comes out to about here, and then shoots down all the way to 17.9. If you can imagine a block like this. Somehow randomly generated, there's no way, there's no path to get to my ship. What happens then? Well, let's march it through. So I go 44.7, 40.8, 36.9, keep marching. And then I come to the point where I'm one block away. I'm here, right? Okay, this is, let's say, positive infinity. So what am I going to try and do? March down all the way to get to here. Then I'm going to march back up to here, right? And, okay, cool, that's there. And then I'm going to go up, because that's the next possibility, and left. And then I'm going to march back to this point. And then there's no path. It's going to stop. There's no place to go. Everything else is marked as closed, and the open paths I've only to, I'm going to stop. And then there's no place to go, right? So the answer is going to be in the console somewhere, no path available. I can't go. There's no clear path to get to there. Okay? Questions around the tiles we've laid out so far today. I'm going to put this up on GitHub for you guys, but this should help you set up your assignment number 2. Set it up for this point now, okay? Just a recap for next week, guys. Next week, remember, tests will be online and remote, starting on Tuesday and working until Friday. You'll be able to hand it in anytime between Tuesday and Friday, okay? 2 attempts. And then we'll meet on lecture on Thursday to go over some additional things for pathfinding, okay? Thanks so much, guys, and I'll see you guys on Thursday of next week, because there is nothing before then, okay? I'm just going to stop recording now. I'm going to put this up on GitHub for you guys.